Imagine solving a triangle without knowing a single angle. What if I told you just one ratio could unlock all the secrets? Distances, heights, and even hidden trigonometric truths. Sounds impossible? Stick around, because today we're going to crack the code using nothing but logic and math. Let's dive in. Here's where it gets interesting. We use a factor called k, a hidden key to unlock the distance. And to find other trigonometric ratios, my friend will show you how to use k-factor to solve questions. So here we go.
So let's start with the trigonometric ratios. You can see a triangle here, ABC. Now, first of all, analyze that which side will be base, which side will be perpendicular, and which will be the hypotenuse. So the side opposite to 90 degree, because it is a right angle triangle, is known as hypotenuse, and the side which has both the angles, the 90 degree and the other angle theta, that is known as base. Now base is also known as adjacent. The side which is opposite to this angle theta is known as perpendicular or opposite. Upon which side you are taking as perpendicular and which side you are taking as base, the trigonometric signs, value and answer will change. The hypotenuse will remain the same, that's the opposite to 90 degree. We are going to talk about the three trigonometric ratios. First is the sine theta. So sine theta is perpendicular upon hypotenuse. I would be representing perpendicular by P, the hypotenuse by H, and the base by B. Right. So in this case, we are going to consider the triangle A, B, and C, which is right angled at B. That means angle B is equals to 90 degree. So here sine theta will be equals to perpendicular upon hypotenuse. Now in this case, which one is the perpendicular? Perpendicular is your AB and your hypotenuse is your AC. Then cos theta, that is equals to base upon hypotenuse. So base is BC here, hypotenuse is AC here. Then we have tan theta. Tan theta is perpendicular upon base. Now here your perpendicular is AB and your base is BC. Now as I've told you earlier, the reciprocal trigonometric ratio. So cosec theta is reciprocal of sine theta. So that means it will be equals to hypotenuse upon perpendicular, that will be AC upon AB, and the secant theta is reciprocal of cos theta, that will be equal to hypotenuse upon base, and that will be equals to AC upon BC. And the last is the cot theta, which is reciprocal of tan theta. So it will be base upon perpendicular, that is BC upon AB. Is that clear? So we would be using these 6 trigonometric ratios. Now in the question, when it comes to find the trigonometric ratios, by default you have to find all of them. Only one of them will be given to you and rest 5 you have to find it out. If just given find the trigonometric ratios and one trigonometric ratio is given, find all the 5 of them. Don't think that you just have to find sine, cos and tan. You have to find the cosec, secant as well as the cot theta also. So in the second case, when the angle is at the vertical vertex of the triangle, so in this case the side opposite to 90 degree will be hypotenuse, and the side which has both the angles, this theta as well as 90, is known as base or adjacent. I will represent it with B. And the side which is opposite to the angle theta is known as perpendicular or opposite. I'm going to represent it as. So in this case, if we consider in this triangle ABC, which is right angle at B, if we are going to consider the trigonometric ratios, so those will be sine theta perpendicular upon hypotenuse. So here in this case, it is BC upon AC, and then we have cos theta, that is base upon hypotenuse. So in this case, this is AB upon AC, and then we have tan theta, that is perpendicular, that is equals to BC upon AB. So cosecant theta is reciprocal of 1 upon sine theta, that will be hypotenuse upon perpendicular, that is AC upon BC, and the secant theta will be reciprocal of cos theta, that will be equals to hypotenuse upon base, that is equals to AC upon AB, and that cot theta is reciprocal of tan theta, that is base upon perpendicular, that is AB upon BC. So depending upon the triangle where the angle is, there will be change in the base and the perpendicular. So I repeat that depending upon where this angle theta is, the base and perpendicular will change. The hypotenuse will always remain the same. You can see here that this is the summary. Here, instead of base, it's being used adjacent. So I have made the figure with this adjacent, and the perpendicular is known as opposite. So whichever way we want to use, the concept will remain the same. The base will be the line which has both the angles, the 90-degree and the angle theta, and the perpendicular or the opposite will be the side which is opposite to this angle theta in the cases. Now let us start with the concept. The first concept is that there will be two types of questions. In one question, the ratio of the sides will be given to you. Let us consider this A, B, and C, and let us consider this as P, Q, and R. That suppose here tan say C, that is given as 4 upon 5. This is just a hypothetical example. So that means we are talking about this angle, and tan is given. Tan is perpendicular upon base, right? So in this case, this is your base, and the side opposite to this will be the perpendicular, and the side opposite to 90-degree is the hypotenuse, right? So now in this case the ratio of the sides are given, so you cannot write 4 and you cannot write 5. This will be wrong. You cannot write because these sides are in the simplest whole number ratio. Now to convert a ratio into a number, you have to multiply with the variable. So what you're going to write, we know that here tan C is equal to perpendicular upon base. Now perpendicular is AB and the base is BC. So we are going to say let the side AB be, what is the value? 4. So I'm multiplying with a variable k. And then I will say let the side BC be. The value of BC is given as 5 and I'm going to take it as 5k. So my AB will be 4k and my BC will be 5k. Now I have converted the ratios into the side. I can use the Pythagoras theorem to find the hypotenuse and the other values. So this is a very, very important trick, that whenever the ratio is given, the ratio sides, like suppose here I have taken that tan C is equals to 4 upon 5. Maybe actual was 16 and 20 sides. We don't know because the ratios will be given in the simplest whole number ratio. So that is why I really don't know what is an actual number and which with integer we are going to multiply. So that is the reason I am multiplying the ratios value with a hypothetical number k, so that I can get the exact values of the sides. Now, in the second type of questions, when the sides are given to you, you can use the actual sides. For example, this is given 20 and this is given 21. So you can use the actual values to find the hypotenuse or other values or parameters. So first of all, we are going to make a triangle, and by default, I always consider the angle mentioned here at the base. Is that clear? So it is better to consider the angle given in the question for which we have to find the trigonometric ratios as a base. Base angle, you can say, that will be easy for you to understand. Now this is 90-degree. So this is your base, this is your hypotenuse, and the side opposite to the angle A is your perpendicular. So BC is your perpendicular, AB is your base, and AC is your hypotenuse. Now in this case, tan A is given to us as 4 upon 3. So we are going to consider that tan A is equals to perpendicular upon base, and perpendicular is BC and base is your AB, that is equals to 4 upon 3. So we are going to consider let BC equals to 4k and let AB is equals to 3k. Now I'm going to put the values here. So my BC is 4K and my AB is 3K. Right. Now this was given in the question and we have segregated what is given to us in the question. So we need to find the other trigonometric ratios. So we have three trigonometric ratios. So that means we have to find five of them. That means we have to find sine theta. We have to find cos theta. We have to find cosecant theta. We have to find secant theta, and we have to theta, right? So in this case, we are going to replace the theta by the angle A. So that means in this case, we have to find cosecant and then we have to find secant A and then we have to find cot A. So before finding all these five trigonometric ratios, we should know the values of all the three sides. We know two sides, that AB is equal to 3K and BC is equal to 5K. So by using the Pythagoras theorem, I'm going to find the side AC. I can write down here hypotenuse square is equal to perpendicular square plus base square. So on substituting the values, that is AC square is equals to BC square plus AB square. So this AC square will be equals to 4K square plus 3K square. Now we are going to solve this. We are going to get AC square is equals to 25K square, and on taking the square root of 25K square, we are going to get 5K. Now we are talking about the distance here, and distance doesn't have any negative value. So in this case, when we are converting the square root into a rational number, we are not going to take plus minus. So here the negative value we are not going to take because we are taking the distances, and distances are always positive. So now my triangle will be like this. This is my A, this is my B, and this is my C. So this is 3K, this is 4K, and this is 5K. I have to find all the five other trigonometric ratios. So first of all, what will be the sine A? That is perpendicular upon hypotenuse, right? In this case, let me first of all write it down. The side having this angle A and the 90-degree is your base. The side opposite to the A is your perpendicular, and the side opposite to 90-degree is your hypotenuse. So perpendicular upon hypotenuse, that is BC upon AC, that is 4K upon 5K. This is going to get cancelled. So your final answer will be 4 is to 5. It will be in the ratio. Again, we don't know about this K. In this case, the K got cancelled. So again, we got the answer in the ratio because we are finding the trigonometric ratios, not the actual values. So here, cos A will be base upon hypotenuse, that is equals to AB upon AC, that is 3K upon 5K. So my answer will be 3 upon 5. So now let us consider the reciprocal trigonometric ratio. The reciprocal of sine A is the cosecant A. So the cosecant A will be hypotenuse upon perpendicular, that is AC upon BC, that will be equals to 5 upon 4. And the secant A is reciprocal of cos A, that is hypotenuse upon base, that is AC upon AB, that is equals to 5 upon 3. And the reciprocal of the tan A is the cot A. So here tan A is given as 4 upon 3. You can write down the value, that is base upon perpendicular. So here your base is 3K and your perpendicular is 4K. That is 3 upon 4. So these are the five trigonometric values. So remember, if in the question the trigonometric value is given, so you will have to find the answers in the term of the trigonometric ratios only. Though we have converted the ratios into the side, because we cannot use the ratios in the triangle, we cannot find the sides with the ratios. So first of all, we have converted the ratio given to us in terms of the side, and we have find out the hypotenuse. After that, we are taking the ratios as per the different trigonometric ratios and accordingly finding the ratios of the. Now here is an example 2. It is given if angle B and angle Q are acute angles. Acute angles, that means when the angle is less than 90 degree, such that sine B is given equal to sine Q, then we have to prove that angle B is equals to angle Q. So now let us consider two triangles, that is A, B and C. This B is an acute angle, and then we have PQR, and R is an acute angle. So it is given to us that angle B and angle Q are acute, and this is given to us sine B is equals to the sine Q, and we have to prove that angle B will be equals to angle Q. We have considered two right angles. This is right angle at C. So in triangle ABC, angle C is 90 degree, R angle Q is 90 degree. So here, first of all, I'm going to take the two triangles. Let this be triangle A, C and B. This is acute angle at B. And then we are going to consider this P, R and Q. This Q is your acute angle. See what is given to us. It is given to us that sine B is equal to sine Q. Before that, we would like to label it. The side opposite to 90 degree is the hypotenuse. The side which has the 90 and the angle is the base or adjacent, and the side opposite to this angle B is the perpendicular. Similarly, the side opposite to 90 degree is hypotenuse. The side which has 90 degree and this angle Q is the base or the adjacent, and the side opposite to angle Q is perpendicular or opposite. Now in this triangle ABC, sine theta is equals to perpendicular upon hypotenuse So in that case, that will be equals to AC upon AB. Similarly, in triangle PQR, sine is equals to perpendicular upon hypotenuse. So that means sine Q will be equals to PR upon P. It is given to us that sine B is equals to sine Q. So if we substitute the value of sine B, it is given AC upon AB, and sine Q means PR upon PQ. So that means this is the first parameter that we got. Now what we are going to consider, we are going to consider that this is equals to K. That is AC upon AB, that is equals to PR upon PQ. Now what I'm doing here, let me label this. This is A, C and B, and this is P, R and Q. So you can see here that AC is the perpendicular of the triangle AC, and PR is the perpendicular of the triangle PRQ. So now we are going to take the similar sides. I am going to take PR here, and I'm going to take AB on the top. So I'm going to rewrite it because I'm taking the similar ratio, that is AC upon PR is equals to AB upon PQ. This is the ratio. AC upon PR is the ratio of perpendicular ratio of both the triangles, and AB and upon PQ is the ratio of hypotenuse, right? So I have taken the ratios and I'm assuming it to be equals to K. So if I see here AC upon PR equals to K, I get the value of AC equals to KPR. And now if I take AB is equals to K, I will get AB is equal to KPQ. This is a very, very important step. This step is very, very important. If you don't take this step and you just put this equals to K, you are not going to get the answer. So remember, you have to rewrite it taking the ratios of the perpendiculars of both the triangles and taking the ratio of hypotenuse of both the triangles, and then you have to make it equals to K, and then find out the value of one side in terms of the another. Now what is the third side left? The side which is left, you are going to take that in terms of the Pythagoras theorem. So remember, we are using the side AC and AB, and in this triangle BC is left, and in this triangle we are using PR and PQ, and QR is left. Okay, so I would be taking these sides which are the left one. So that is the technique I'm going to tell you. You have to do it for the similar kind of questions. Now you have to take into accordance the Pythagoras theorem in terms of the side which is left, which you have not taken in the ratios. Remember, don't take the sides which you have taken in the ratio. Is that clear? Otherwise that is not going to give you an answer. So this is what we have. It is A, C and B, and this is P, R and Q. Now if I take the triangle A, B and C by Pythagoras theorem, that will be equals to AB square, that is equals to AC square plus BC square. So I would be taking that AB square minus AC square equals to BC square, or I can write it down that BC is equal to square root of AB square minus AC square. In triangle PRQ, again using the Pythagoras, we can take PQ square is equal to PR square plus QR square. So PQ square minus PR square is equals to QR square, or I can get QR is equals to square root of PQ square minus PR square. This is the value of BC and this is the value of QR. Now you must be thinking that what I'm going to do now. Now what I'm going to do, I'm going to take the ratio of these two sides and I'm going to substitute the value of AB and AC where I found out. So I'm going to substitute the value of AC and AB. Then accordingly I will get the answer. So now I am going to take the ratio of BC and QR. So BC upon QR is equals to, this is AB minus AC square, and this will be PQ square minus PR square. So your AC is KPR and your AB is KPQ. I am substituting the value of AB and AC here. Remember to substitute it, because in the numerator only you will be substituting both the values. So this will be K PQ whole square minus K PR whole square, and this will remain same, that is PQ square PR square. Now let us solve this. BC upon QR, that will be equals to K square PQ square minus K square PR square divided by PQ square minus PR square. So here I can take K common. K square out of the square will become K, and we are left with PQ square minus PR square divided by square root of PQ square minus PR square. So I will cancel it out. Now you must be thinking why I have done this step. I have done this step so that I can prove the ratio of the third sides. Here this is your ACB and this is your P, R and Q. So we can prove the ratio of the third side is also equals to K. You can see here that the ratio of the two sides is equal to K. Now I have to prove that the ratio of this third side is also equal to K. Why? When the ratios are equal, then the triangles will be similar. Now when the triangles are similar, the angles will be equal. So now we know that AC upon PR equals to AB upon PQ is equals to K, and we have just proved that C upon QR is equals to K. So from first and second equation we get that AC upon PR is equal to AB upon PQ is equal to BC upon QR. So in triangle ABC and triangle PQR, ratios of sides are equal. Now when the ratios of the sides are equal, that means the triangle ABC and triangle PQR are similar. That means triangle ABC is similar to the triangle PQR. So now if two triangles are similar, then their corresponding angles are equal. Now, what does I mean by the corresponding angles? So this is triangle ABC is similar to the triangle PA will be equals to angle P. So let me write it down here. This is A, C, B and P, R, Q. So now this angle A will be equals to angle P. This angle B will be equals to angle Q. Angle B and angle C is equals to angle R. That we already know, that is 90 degree. So we needed to prove that angle B is equals to angle Q. So we have proved. What are the steps that I have done? The first step is that I have taken the ratios of similar sides of two triangles, and then I have assumed them and found value of one side in terms of another. Now the third part is that have taken side using Pythagoras theorem, and then I have substituted the value of side. Now the fifth is that then as triangles are similar as sides are in ratio. So the sixth is that angles. So these are the steps that you need to understand. I'll just quickly recap. First of all, what is given to us, I have taken the ratio of sides. Here I have rewritten it and I have taken the ratios of the similar sides, perpendicular upon perpendicular, hypotenuse upon hypotenuse, and I have taken is equal to k. Now I have found out the value of one side in terms of another in terms of k. That means AC is equal to kPR and AB is equal to kPQ. Now the third side which was left, I have found out its value taking the Pythagoras theorem. That means BC is equal to AB square minus AC square. Then QR is square root of PQ square minus PR square. Then I have taken that ratio and I've substituted the value of AB square and AC square, and I have cancelled it, leaving only the K. That these two will get cancelled. Now the third side ratios are also equals to K. On comparing, we got the ratios of the perpendicular and the ratios of the hypotenuse. This is the perpendicular and hypotenuse equals to k, and we got the ratios of the bases also equals to k. So we got that the ratio of all the sides are equal. Now a ratio of all the sides are equal, so that means these two triangles will be similar. Now if these two triangles are similar, then their corresponding angles are also. That means in triangle ABC and triangle PQR, angle A will be equals to angle P, angle B will be equals to angle Q, and angle C will be equals to angle R. So we have proved that angle B will be equals to angle Q. Into cos A equals to 1. This is your left hand side and this is your right hand side. So finding the values, first of all we have to find the value of sine A. Now let us see what value we got. This was root 2k, this is 1k, and this is 1k. So sine A is perpendicular upon hypotenuse. So this is your base, this is your perpendicular, and this is your hypotenuse. So that is equals to BC upon AC. That is 1k upon root 2k. And your cos A is equals to base upon hypotenuse. So your base is AB upon AC. That is 1k upon root 2k. Now we are going to solve the left hand side. That is 2 sine A into cos A. Remember in trigonometry this dot means multiply. So this is 2 sine A, that is 1k upon root 2k, into cos A, that is 1k upon root 2k. K and K will get cancelled. And this will be 2. Root 2 into root 2 is 2. That is equals to 1. So our left hand side is equals to right hand side. So verified.
Now that you've understood how to use the K factor to solve trigonometric ratios without knowing the angle, if you're curious to learn how to calculate distances using values of angles, like tan, sine, and cos, or want to dive deeper into solving trigonometric identities, make sure to check out our other videos and stay tuned for more. Don't forget to like, share, and subscribe. Thank you.